Hello, boys and girls. Make sure you guys are turning to page 7. We are on lesson 2 homework. For problem number 1, they ask you to show each expression on a number line and then solve. So, when we're adding fractions with similar or like denominators, then you can just add straight across. Later on, you'll notice that there are going to be unlike denominators, and that's when you are going to be changing more than what you just see. So, right here, we are adding together, I'm getting a highlighter, 4 plus 1, which is equal to 5. So this is called the numerator. And the numerator is the number that is on top of the fraction bar. And the number on the bottom is called the denominator. So that is the number that is on the bottom. If it helps you, I kind of think denominator down, the number that is down or below, 5, or the number on top is called the numerator, the number that is up. So this number, when both of them are the same in adding or subtracting, you do not change it. So you don't add 9 plus 9 is equal to 18. You leave it as 9. So you leave that number alone, okay? The number on top does change. 4 plus 1 is equal to 5. So that number changes. So that's what you see here. Now they want you to put it onto a number line so that you can see it visually, how it looks like. So right here, I marked my number line. I have 0 at the beginning, and I went from 1 9, 2 9s, 3 9s, 4 9s, 5 9s, 6 9s, 7 9s, because it's over 9. So I'm adding right here 4 9s. So I'm going all the way 1, 2, 3, 4, 4 9s. Here we have 4 9s. And then they want you to add 1 9. So 1 9 is just 1 over. So my final answer is equal to 5 9. That's how you find it on a number line. Wow, that's kind of hard to see. Now on this side, for problem B, they're asking you to add 1/4, 1/4, 1/4, 1/4 plus 1/4. And 1 plus 1 plus 1 plus 1 plus 1 is equal to 4. Okay? And on the bottom, you don't change that number. 4, 4, 4 stays the same. It does not change at all. Now, remember I told you before that this bar right here is called a division bar. So 4 divided by 4 is equal to 1. So to show that on a number line, I marked my fourths. So right here I have 0, and then I have 1/4, 2/4, 3/4, 4/4, 5/4. I added the 5/4 just in case I needed it. And now I'm adding 1/4 plus 1/4 plus 1/4 plus 1/4, which is equal to 4/4. Okay, and that is our answer. 4/4 is equivalent to 1. Okay, and then we have problem C. For problem C, you are adding right here 2 7s plus 2 7s plus 2 7s. There are 3 2 7s. So on the number line, I marked 0 and 1, and these are all divided into 7s. I didn't have enough room to write it down, but they're divided into 7s. Okay, so I have 2 7s. I know that 2 plus 2 plus 2 plus 2 is equal to 6. And then 7 plus 7 plus 7 plus 7, remember that doesn't change. The denominator does not change. So I keep it as 7. So I have 6 7s as my answer. So I'm going to show you here. So we went 2 7s, and then 2 7s again, and then 2 7s again, and that is going to get us 6 7s. On this side, I have 2 times 3/5 plus 1/5. So this is interesting because first what you want to do is you want to make sure that you are adding, either you start at 2, go over 2, or you are going to add these numbers together. But definitely make sure that these numbers stay together. So I know that 3 plus 1 is equal to 4, and 5 plus 5, I don't change that. Denominator, you do not change. So you keep it the same at 5. So the number 3 plus 1, I'm highlighting it so you guys can see it better, and 5 plus 5, or 5, stays the same. And now don't forget this 2. This 2 doesn't change. You can leave it right here as a whole number. So now I'm going to move over 2 times. So I have 0 fifths, 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths, 6 fifths, and 5. So I'm moving over to, first I'm going to move 3 fifths, and then I'm going to move 6 fifths. So I have 3 fifths, and then I'm moving over 6 fifths, and then I have 1 fifth. Okay, so that's going to give you 2 and 4 fifths in all. And 2 and 4 fifths is equivalent to 7 fifths. Oh, sorry. It is also equivalent to 10, 11, 12, 13, 14, 14 fifths. So this actually needs to go a little bit further. I'm noticing this number line is not correct. And I don't know if it will fit. But if we were to continue this number line, it would go all the way to 14 fifths. You don't have to draw this. I know it's a little hard to draw all of them. So if you can't fit all of it, that's okay. But it's going to go all the way to 14 fifths. Right? Because we are adding 3 plus 1 is 4, and 5 plus 5 is equal to 5 and 5, so we have 2 times 4 fifths. So we have 2 and 4 fifths, which is 14 fifths. Yep. Okay, for problem number 2, it asks you to express each fraction as the sum of 2 or 3 equal fractional parts. Rewrite each as a multiplication equation on number line. So right here we have 3 11ths plus 3 11ths, because you can split 6 into 3 and 3, okay? Because 3 plus 3 is equal to 6. So that's what I did here. I split it and the denominator stays the same. So 6 has been split into 2, 3 and 3, and 11, the denominator stays the same. For this one, all you need to write is 2 because there are 2 of them, and times 3 11ths, and they are the same. Over here for problem B, I have 9 fourths. I can split 9 fourths, or 9, into 3. So I have 3 plus 3 plus 3. Okay, so there are 3 3's at the top for the numerator. And on the bottom, my denominator stays the same, so it is 4. Now, how many do you have here? You have 1, 2, 3. So 3 times 3 fourths is going to be the multiplication equation. Now for this one, we have 12 eighths, and I split 12 in 6 plus 6. So I have 2 6's at the top. And on the bottom, I have 8 because the denominator stays the same. Okay, so there's 1 and 2. So 2 times 6 eighths is the same as 6 eighths plus 6 eighths. For problem D, I have 27, and I can split that into 3 9's. Because 9 plus 9 plus 9 plus 9 is equal to 27. So there are 3 of them. So I multiply 3 times 9 tenths. So at the top, we have your numerator, and on the bottom, you have your denominator. Okay, now we're going to turn the page. For problem number 3, it says express each of the following as a sum. Remember, sum means adding the answer to an addition problem. Of a whole number and fraction, show parts C and D on number lines. So we are not going to do the number lines because there is not enough space. However, we're going to solve for it. So we have 5 9 fifths, and you can split that into 2. So 5 and 4 makes 9. So we have 9 fifths, 5 fifths plus 4 fifths. So let me show you. We have 5 plus 4, because 5 plus 4 is equal to 9, which is the same for our our numerator and our denominator, we have 5, 5, 5, which stays the same. Now, 5 divided by 5 is equal to 1. It is the same as having 1. They are equivalent to each other. So that's why I'm writing 1 right here, plus 4/5. Okay? Now, what I'm going to do is I'm going to make sure that I write 1 and 4/5, but you can also write it like this because it is the same. It is equivalent to 1 and 4/5, just like that. You don't have to put the addition sign. For problem B, we have 7 halves. So 7 can be split into many, right? So we have 2 plus 2 plus 2 plus 1. Because 2 plus 2 is 4, plus 2 again is 6, plus 1 is 7. So we can add all of those together. So we have 2 halves plus 2 halves plus 2 halves plus 1 half. And notice at the top, you have your numerator is added all together. You get 7. And on the bottom, you have your denominator that does not change. Now, 2 divided by 2 is equal to 1. They're equivalent. So I'm writing 1 plus 1 plus 1 plus 1 half, because this one is not 2 over 2. So we have 1, 2, 3, 3 ones, and 1 half. Over here, we have 7, 7, we have 25. And I can split 7, or I can split 7, so I have 7, 7, 7, which equals to 21, and then I add 4, which gives me 27. So that's why I have 7 plus 7 is 14. 7 plus 7 again is 21. 21 plus 4 is equal to 25. And our denominator is 7. So I have 1, 7, 2, 7, 3, 7, 4, 7. Remember, denominator does not change. So right here we have 1. Let me do this as a two-step problem. We have 1 plus 1 plus 1 plus 4 sevenths. So there is 1, 2, 3, and 4 sevenths. Okay? Now over here we have 21. So I'm going to split 21, 9 plus 9 plus 3. 9 plus 9 is 18 plus 3 gives me 21. Just like how over here I added all of those numbers together. So 9 plus 9, I'm going to do 2 steps so you guys can see it as 2 steps rather than just 1. 9 divided by 9 is equal to 1. 9 divided by 9 is equal to 1. And then we have 3 9s. So 1 plus 1 is equal to 2. And we have 3 9s afterwards. So it's 2 and 3 9s as my final answer. Now for problem 4, Natalie sawed 5 boards of equal lengths to make a stool. Each was 9/10 of a meter long. So she has 5 boards that are 9/10. We have 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. And each of them are 9/10 meter long. What is the total length of the boards she sawed? So we want you to add all of those numbers together. So 1, 2, 3, 4, 5. 9 times 5 is equal to 45. So I know that it's 45/10, but they also want us to express my answer as a sum of a whole number. So I need to show my addition. I put 10 tenths, 10 tenths, 10 tenths, 10 tenths, because if I were to split this, I can split it into 1, 2, 3, 4, right? And then I have 5 tenths as a remainder. So 10 times 4 is equal to 40, and then I added 5 tenths. I know that 10 divided by 10 is equal to 1. 10 divided by 10 is equal to 1. 10 divided by 10 is equal to 1. And my remainder is 5 tenths that I have left. So my final answer is 4 plus 5 tenths, or 4 and 5 tenths as your final answer. Okay? And that is all for today. Please let me know if you have any questions in class.